Alright, this is number 2 from the 2011 Form B AP Physics B exam, and it is primarily an electrostatics experiment problem. And we've got ourselves a positive charge of unknown mass, or sorry, of known mass, it's a ball, that we are going to then design an experiment to determine a bunch of stuff. Ultimately, we're going to take two plates, oppositely charged, and do something. So here we need to check off our materials. Here we need to sketch it. Here we're going to discuss the experimental procedure. And then way down here we're going to start to get into the quantifying of everything. To explain A, B, and C, I want to explain the experiment. And I am going to use the same experiment that the scoring guidelines suggest, because I do believe it is the best. But understand it's not unequivocally the only way of doing this. And so what is suggested is we're going to have the plates separated, so there's a potential difference between them. One of them's positive, one of them's negative. We're going to take the ball and we're going to suspend it from a string in the middle of these two plates. So when everything's off, it just hangs straight down. Okay, it might be attached to more of an apparatus. We don't need to worry about that. Behind the ball, behind this back plane here, we're going to have a screen. And then we're going to take a protractor and we're going to hang it down off the top of the screen so we can measure the angle of this ball once it sways left or right. But a great way of seeing this ball clearly without putting the protractor right to it is to actually have a light source that is going to cast a shadow on the screen behind it. So this is the setup, label everything, but then if there's a shadow here, when it's hanging straight down, you'll see it like this, and then when it sways outward, one way or the other, you'll see that shadow change and you'll be able to measure that angle. So you should label everything. So we've got screen, protractor, plates, light source, and then the ball itself. Charged ball. So, what do we need here? Well, we're going to need the protractor. We're going to need the screen and the bright light. We're probably going to need some sort of reference tool. A center line. So you may or may not check the meter stick. I don't think you have to. Maybe the metal rod, some sort of reference. I don't even think you absolutely need these as long as you explain how you're going to do everything properly over here. So this is A and B. I've got the sketch done as well, and then the experimental procedure, including the quantities in which you're going to be measuring, and then the equipment and how you're going to do that. So ultimately, you're going to need to have a data table where you have the original 0-degree mark measured, no electric potential at all. Mind you, this charged ball is positive. So then you're going to need to indicate that you're going to shine the light on the ball so it casts the shadow on the screen. You're going to then need to turn the electric potential source on and allow the ball to move either right or left depending on the direction of the field, and it will then suspend itself at some angle, and you're going to measure that angle. You're going to indicate that. You're going to use the protractor to measure the angle. You're going to put this all in a data table. D says how are you going to calculate the magnitude of the electric field, then how are you going to determine the direction of the electric field, and then how you would determine which plate is positive. So for D, I want to draw a Freebody diagram to help explain this a little bit better. And when the ball is suspended, let's say it's suspended to the right, the shadow will look something like this. So I want to draw out the Freebody diagram here. We have a tension here holding it out. We have the weight of the ball down. And because that weight of the ball can only be canceled out by the y component of tension, there needs to be another force to the right to cancel out the left component of tension, which is the electric force. Now mind you, the protractor is hanging down like so. And so the angle that's being measured is this angle up here. So if we set up our dynamics, sigma Fy must be 0, which is going to be Ty minus mg. And Ty is adjacent to my angle theta, so it's going to be T cos theta equals mg. And the x dimension is going to be very similar but opposite. It's still 0. It's going to be Tx minus Fe, or T sine theta is equal to the electric force. Now the electric force is equal to E times Q, so the electric field is going to be the electric force divided by Q, and that's what we need, is electric field. So I want to first put this in terms of, not in terms of, but I want to get rid of my tension, because I don't know tension. I do know mass, so I'm going to do a little bit of math here. I'm going to say that the tension is going to be mg divided by cos theta. Now I'm going to replace this red bit in for t down here to show that mg sine theta divided by cos theta is the electric force, but sine over cosine is tangent. So really the electric force is going to be mg tan theta. Since the electric field is force over Q, the ultimate final answer I need is mg tan theta divided by the charge of the particle. And that'll be it for part 1 for part D. Now part 2 says, how would you determine the direction of the electric field? Well, if the ball is positive, you got to remember electric field always points in the direction in which a positive charge goes. So if the ball is swaying to the right, then you know the electric field is directed to the right. And if the ball swings to the left, then it's directed to the left. So simply indicate that the field will be in the same direction in which the ball is deflected. 3, how would you determine which plate is positive? Using the same thinking, if we know the direction of electric field, then you know which one the positive plate is. And remember, electric field always goes from positive to negative. So if the electric field is pointed to the right, then the positive plate is the left plate. Alright, that's it for number 2 for this problem.